Dad, I have a question. I would like to know why me and my brother have a big age gap.
That's a good question. You're old enough to grasp the details, so let me give you the whole story. Back in those days, contraceptive options for men were limited. There were condoms, which, let's face it, aren't foolproof. And then there was a vasectomy, which was a big decision, was expensive, and not easily reversible.
I see.
So your mom and I relied on condoms, but as luck would have it, you came along. Sorry about that, but we're so glad you're here. After you were born, I didn't know which method to choose, but deciding on contraception was tough. Vasectomy wasn't appealing at the time, but we needed something reliable. That's when I stumbled upon a new male, non-hormonal contraceptive. It piqued my interest, and I decided to give it a shot. In fact, let me show you a video I found that explains it better.
There's a new pill on the market, EPPINESS. This pill has as its target the sperm protein EPPIN, which is present on the surface of human spermatozoa. EPPIN acts as a central node for protein-protein interactions that regulate sperm function upon ejaculation, and has three functions. It is a bactericide, an inhibitor of PSA enzyme activity, and a protein that binds the seminal plasma protein, seminogelin, also known as SEMG1. In a normal fertilization scenario, the binding of EPPIN by SEMG1 causes a loss of sperm function manifested as a loss of forward or progressive motility. Subsequently, that motility is regained because the Proteus PSA degrades SEMG1, removing it. To discover EPPINESS, some approaches were explored, including the search for a small organic compound to substitute for SEMG1 or an anti-EPPIN antibody. The consequences of their actions are a decrease in sperm internal pH and internal calcium levels, which causes a loss of sperm function. Therefore, two studies were developed to create this pill. One of them in vivo using macaques, where a new lead compound that binds the protein EPPIN was tested, and the other one in vitro using mice whose sperm received two types of antibodies to see if they inhibited sperm motility. In the study in vitro, mice were a good experimental model since they have a vesicle-secreted protein 2, SVS2, that binds to EPPIN, having the same function as SEMG1 in humans. They isolated mouse epididymal spermatozoa, incubated them with anti-EPPIN S21C antibody that binds to the C-terminal of human EPPIN and anti-EPPIN Q20E antibody that binds to the N-terminal of murine EPPIN, and performed fertilization in vitro. The movement and motion patterns of sperm cells were analyzed, resulting in the following findings. As the graphs show in red, both the S21C antibody and its Fab fragment, which is the antigen-binding portion of the antibody, decreased progressive and hyperactivated motility compared to the controls shown in black. The Q20E antibody and its Fab fragment, shown in blue, induced a milder inhibition of sperm motility. The incubation of these antibodies with sperm decreased the oocyte cleavage rates in the percentage of two-cell embryos following IVF. This study demonstrates that the binding of antibodies to the N and C-terminal domains of EPPIN decreases the reproductive efficiency of spermatozoa, showing that mice are reasonable experimental models to study EPPIN ligands in preclinical trials. From a pharmaceutical perspective, an antibody is not very useful, so let's move on to the small organic compounds. So in the study with macaques, a small organic compound similar to SEMG1 with multiple substitutions on a 1,3,5-triazine ring structure that binds to the C-terminal domain of protein EPPIN was developed. This compound is EP055. Studies show that EP055 binds EPPIN and inhibits human sperm motility in vitro. Therefore, it was tested whether it inhibits sperm motility in vivo in macaques. The macaques were infused intravenously with a low dose and a subsequent high dose of EP055. So sperm motility can be correlated with semen levels of EP055, following both the low and high dose infusion. In animals receiving the low dose, EP055 was still evident in semen at 30 and 78 hours post-infusion. But by 30 hours post-infusion, normal sperm motility fell below 32%, which is equivalent to subfertility in men. Following high-dose treatment, semen EP055 levels increased significantly relative to baseline and remained elevated between 6 and 30 hours. By 6 hours, post-infusion sperm motility fell significantly in all the animals to approximately 20%, and no normal motility was observed at 30 hours post-infusion. EP055 levels then declined, but were still evident in semen collected 78 hours post-infusion. Then there is a full recovery of normal sperm motility in all animals by 18 days post-infusion, indicating a reversible effect, and the macaques remained healthy, with no indications of side effects during or after drug administration.
EPPINESS was created in 2027, and that's how your brother came to be. A planned pregnancy, a dream carefully prepared and realized. Unlike you, who came into the world unexpectedly, but just as loved and special.